we're going to be looking at midpoint. And we've talked about distance, and we're talking about distances. We're going to actually use the midpoint, because the midpoint actually has to do a little bit with distance. When you have a segment and you've got two endpoints, there's what we call a midpoint. And it's exactly like it sounds. It's the actual middle point. It's exactly in the middle between the two endpoints. The proper definition is that it is equidistant, which means the same distance from the two endpoints on a line segment. So up in this picture, if M is my endpoint, is my midpoint, that means it's the same distance from A, this endpoint, as it is from B, that endpoint. So the midpoint is the equidistant from the two endpoints. So M is 5 centimeters from B and M is 5 centimeters from A. Now the way we write that is that the distance from A to M is equal to the distance from M to B. So those are equal distances. The other way we can write it when we get into what we call congruence is that segment AM is congruent to segment MB. Notice I've got the segment symbol above, so now I'm talking about an object, not an actual numeric value. Distance and length, we're talking about an actual numeric value. Congruence, we're talking about the object itself and not only the numeric value but the shape. So same size, same shape, they're congruent. So let's look at the midpoint on the coordinate plane. So if I have a coordinate plane, and I put a segment on this coordinate plane and I want to find the midpoint of that segment, then I'm going to use the midpoint formula, which we'll introduce you to. And the midpoint formula is actually just finding the average of the 2 points. So we're actually going to look at it without the midpoint formula first and see if we can solve it and if it makes sense. So I'm going to give you 2 points here. Let's do this point here, and we'll call that point P. And point P is over 2, up 1, so -2, 1. And we'll do a point over here. Let's put a point here, and we'll call that point Q. And that's located at 6, -3. So between P and Q, I'm going to draw a segment. And I want to find the midpoint of this segment. I want to find the point that's exactly in the middle of that line. So what I have to do is I actually have to find a halfway point. Well, when you're looking at a slanted line, it's not as simple as when you're looking at a horizontal line. If I were to give you a horizontal line, let's say we have a number line. I'll give you a number line right here. We'll do an example. So we have 1, 2, 3, 4, 1, 2, 3. Let's say I've got a point here at -3, and I've got a point here at 4. Let's say this is S and this is T. And I want to find the point that's halfway between those two. So basically the midpoint of segment ST. What I would do is take the average. We talk about in class how if you make 100 on a test and you make a 90 on a test, your average is 95. How did you get that? You took the two values, added them together, and divided by how many values you had, which was 2. So we're going to do the same thing to find the middle here. We're going to do -3 plus 4, and we're going to divide that by 2. So -3 plus 4 is 1, so that's 1/2. So your midpoint on the number line is 1/2, right there. That's your midpoint. And if you look at it, it is the same distance away. It's 1, 2, 3.5 away from 4, and it's 1, 2, 3.5 away from S. So let's look at the coordinate plane now. When we're on the coordinate plane, we're going to have to do this operation not only once but twice, because now we have to find the average of the x's and the average of the y's. So let's do that. Let's look at our two x coordinates. I've got -2 and 6. If I told you to find the halfway point between -2 and 6, you would do -2 plus 6 divided by 2, right? You take the average of the two, or you could count. A lot of you could count. There's going to end up being 8, okay? 8 all the way across, and we find the halfway point. That's going to end up being 4, okay? 4 units from the end. When we take that distance, we have -2 to 6, that's 8 units, Half is 4, so what you would do is you would go 4 from 6, which would put you at 2, or 4 this way from -2, which also puts you at 2. So that's a third way to do it. But I'm going to find the average, so -2 plus 6 is 4 over 2, which is 2. So my x-coordinate for my midpoint is going to be 2. So now let's look at the y-coordinate. Well, my y-coordinates are 1 and -3. So I'm going to do 1 plus -3 divided by 2 to find the average. So you're going to get -2 over 2, which is -1. So my y-coordinate of my midpoint is -1. Therefore, I'm going to go on my line, plot my midpoint, and it's at +2, -1. And if you look at that, it actually looks like it's right in the middle. So that came out pretty well. So looking at what we did an average of the x's and we did an average of the y's. Just common sense, finding the halfway point. Well, we actually have a formula for it, but I wanted to show you how to do it without the formula so you understood the origin of the formula, where it comes from. The midpoint formula states the average of the two x-coordinates, which is what we did right here, is the x-coordinate, and the average of the two y-coordinates is the y-coordinate of your midpoint. So there's the formula, but you see where it comes from. You can actually solve this without the formula, and you're technically using the formula, you just don't realize it. It's the average of the two x's, the average of the two y's. That's all you have to remember to find.